Good morning, friends. Today we will talk about Sharable C Program. Okay, this is the basic structure of a C program. We'll have a documentation session will be there where we will write about the program, about the author, such things. Then a link session will be there where we'll include the header files. Then definition sessions, some if mainly used in macros. When we want to write macros, we will go for the definition sessions. Then global declaration part is there where we will include the global variables, global declarations. Then main function will be there. In the main function we'll have the declaration part, execution part, all that things will be written. Then subprograms will be there, a lot of functions will be there, functions and number of functions we can write. So even though the structure of the C program is like this, we will be using this structure less. We will be using one or maybe the main function we will be using every time. Then link section will be used, and sometimes we will be using the functions. So in the modular programming, we will be using the functions. When we are thinking about modular programming, we can assume like this: the user is working at the main, and the implementation will be done in the functions. So user will ask for something to the function, and some function will implement that and return back the and so we can assume like that. Okay, so in order to see this more clearly, we will say take an example. Okay, so we'll take an example of a stack. Stack is last in first term, means whatever we are inserting, the last element we inserted will be deleted first term. That is a stack. The stack have different functions like push, pop, is empty, peek. A lot of functions are there, but in order to simplify the things, I have taken only two functions, push and pop. Push function is to push the element or insert the element into the stack, and pop function is used to delete the element from the stack. So we will see an implementation of stack using arrays. Okay, stack implementation. For stack implementation, we will use an index variable. For array, we will have an index. For stack, that index variable is specially named as top. So initially the top value is -1. So this is the array. Initially top value will be -1. And size is there. I created an array of size 100. Okay, I have used a function. Create stack function is used. This may not be needed. This we can read it. Okay, we will declare like this index size as enough. So variable is a size that according to the user requirement, the size of the stack will be set up, even though size of the array is 100. Okay, so these two functions are there, push and pop. You see the push function. Push function is used to insert the element. So push function returns nothing, so it needs an input argument. So one item will be inserted. Okay, then initially the top, if the top equal to size -1. As top is starting from -1, we can set it like this: top equal to size -1. That means stack is full. Otherwise, we can insert the elements. So currently, this top value is -1. It will be incremented to 1. It will be incremented to 0th position, and to that a of 0 item will be inserted. Next, again we will call. Then it will be inserted in the first position. So like that, it is been inserting the elements. Next, take about the pop function. Let's talk. Pop function returns the element deleted. Okay. So initially top value is -1, so that means the element stack is empty. So it will return 0. 0 0 indicates that the stack is empty. Then otherwise top will be returned and it will be decremented. A of top will be returned. So initially I am inserting an element, then it will be top will be in the first position. The first position element will be popped out and returned, and top value will be decremented to -1, like that. The other functions are there. We are not discussing that. That's not our topic today. Okay, so we'll take about the main. Okay, in the main function we have initially the user is being asked to enter the size of the stack. So I'm going to insert that size. Then to that function creates stack size, inserting that to create stack size. Then I'm using a do while loop. In that I'm asking for entering the options. If 1, it will be pushed, 2, it will be popped, 3, exit. So this process will be continued. Element will be inserted, element will be read and inserted, element will be popped out, and if the element popped out is 0, stack is empty. Otherwise stack is not empty, element will be popped out. So if the choice is 3, then it will be executed. This is a simple program. Okay. So in order to run this free program in command line, we have to use some compiler. So I am going to use a GCC compiler, GCC space file name.c. This is a format for compiling. So for this example, the file name is stack1. So GCC stack1.c. I will compile that. So after compilation, we will get an executable code. In the case of Linux, it will be in a.out file default. For Windows, it will be a.exe file. So I just want to run that. We will just run that code. GCC stack1.c. It will be compiled. Then I'm going to run that a.exe. Enter the size is 3. Element 1 12 is being inserted. Element 1, our choice is 1. 13 is being inserted. Choice is 1, again 14 is being inserted. Choice is 1, again 16 is being inserted. Cannot be inserted, stack is full, only 3 size. I am going to pop out the element. First popped out element is 14, next 13, then 12. Stack is empty. Simple stack code. Okay, I will give 3 later. Exit. Simple structure. So we are using some of the parts of the sessions that we have explained earlier. Okay. So now we will go for a different approach. As I said, the main is assumed to be the user end, and the functions are functions we use to implement that. The user will be asking something, and it will be provided by the function. So what we are going to do now is that we are going to separate the user end and the implementation part into two. Okay. So stack implementation we are going to modify. So what modification we have done, we will see. So I have written another file called the stack.c file. And the same code is there. Only difference is that I have removed the main from that file. We don't have the main, only the implementation code is there. Okay, the same code. Okay. Next, what I want to do, I want to compile that. I want to check whether any error is there, something like that. Okay. For that, normally for any C program should have a main. So we don't have the main there. So instead of compiling this, we will use the -c option and this gcc -c file name.c. This option will allow us to compile the program without main. So gcc -c, so file stack.c, it will be compiled. Normally after compilation, we get an executable code, but here we will get an object code. That object code can be shared. Okay. So what we will get is a stack.o file. It's an object file. This file can be shared. So how to share? So in order to share this, the first step is I separated the main part, deleted this main part, and compiled the remaining part. And what I get is an object code with extension open. What I am saying is that this object code can be shared to other programs. Okay, so in order to share this, we need another file called header file. a header file is needed, because object code we cannot see anything, we cannot read anything, user cannot identify what are the things available in that object code. So in order to provide that information, we need a header file. That header file will specify what are the things available in that object code. We will see that .h file is there. Stack stack.h file is there. Instead, here I will just write the prototype of the functions used. So what I am saying is that okay, this is the functions I am going to use. Push function is there, pop function is there, all the things are there. Only the prototype I will specify. So what is the use of this? Is the user can see. So those who want to use this object code, they want to know what are the things available. So in order to check that, it will use a .h file. Okay, when we open that O file, what we can see is stack.o files. So nothing we can read from this. Okay. So I will create, the next step is we will create a stack.h file. Okay. After this, I want to execute the code. So I need the main. So main is written here, running stack.c. So the same main we explained. Only difference is in different file. Okay. I defined it as run_stack.c. Okay. With that header specified. Normally we will specify the headers like this #include with this greater than less than simple. We will use this header file. But this header file is a local header file. So what we use is we use double quotes. So inside the double quotes we will specify that header file. Okay. Now this file can use that stack.o file. Okay. So in order to so we want to run that run_stack.c file. So while running the file, we have to pass the stack.o. You will see that example. So first of all, I will compile this using -e option. I will compile the stack.c file. So I will get an object code. Stack.o file is available. Now I will create a header file. .h file is there. So I want to run that run_stack.c. This file to this file we are going to pass stack.o object. Stack.o object is being passed. So I'm going to run it. So same code, size is 3, 1, 12, 1, 13, 1, 14, 1, 15. Stack full is there. I'm going to pop out the elements 2, 2. Stack is empty. Same code. Okay. So next thing, why we need this? Because we can write everything in the same file. Why we need to split that? Okay, let's see an example. One of the application of stack that we implemented is used to convert an infix expression to a postfix expression. Infix expression means we have the expression a plus b that should be converted as ab plus. So set of rules are there for conversion. So we want to convert that. Okay. While in conversion, we have to use the stack. The simple logic is that when operand comes, it will be put into the output. Operator comes, it will be pushed to the stack. So that's the process. So a plus b, that means a will be returned to the output, plus pushed to the stack. B returned to the output, plus is in the stack all the elements has been read, so element will be popped out. This is a simple example. A lot of other conditions are there. So while implementing this infix to postfix, we have to start from the scratch. So first of all, we have to either copy the stack functions that we have already implemented and put in this file. So the size of the program will be large. Or we have, that's one option. But here we don't want to use that. We will see that example. So infix to postfix. This is our code. This code will contain the conversion part and the execution, evaluation of the expression. Both the things are there. So I have written certain functions. So in order to check the precedence order, I have written a function precedence. Infix to postfix conversion function is there. In that function, I want to use this push function. Push function is needed. Another function is empty is needed. Then a lot of other functions are there. Peak function is there. So all that pop function is there. All that functions is there. So I modified the stack function. So these functions are needed. And the postfix evaluation part is also there. So what I did is I just include the header file #include stack.h with this code. That means this infix to postfix code can use the stack. Okay. I will show you how to run this. So I want to execute this code. This code does not have the okay. So what we will do is we will use the command gcc with -c option with infix to postfix. So functions there. So I want to execute that gcc infix to postfix with -c option. So I will get an object code. Object code is there. Infix to postfix.o object code is ready. Now I will write a function run infix to postfix. So this is the user and main is there. I will input an infix expression. It will pass to that infix to postfix function. That's the infix postfix function. This infix to postfix function will use the push and pop functions and all other remaining functions to convert the expression. Okay, and return that particular value. A value will be popped out. Then finally the output expression is being evaluation is also being done. So I want to run this code. So while running, I want to run. So gcc run infix to postfix space. So it need two object codes. One infix to postfix.o object code is needed with stack.o object code is needed. So it is passing two object codes. I'm going to run that. So I'm going to expect an expression 1 plus 2. So we'll get 1, 2 plus with string. So programming will be very simple because we are now concentrating only on the infix to postfix. This code contain the infix to postfix conversion part only. Remaining things are not available. Only the that part, evaluation part. Only thing I want to do is that when I want to share, I have to create an object code, and in order to share, I have to create a .h file also. Okay. That .h file has been included here. .h file is been included. This is a good approach when we are writing large programs, because the size of the program can be reduced. We don't want to copy everything. When we are copying things, it will create there may be a chance of getting errors. We are not copying anything, just sharing the code. Okay. So any questions?